Question number 7, that is the last question of this paper. In this question, there are three concepts. There are three key points in this question: kinematics of motion in a straight line, Newton's laws of motion, and inclined plane motion. These are the key points in this question: kinematics of motion in a straight line, Newton's laws, Newton's second law of motion will be used here, and the Newton's third law of motion will be used, and inclined plane motion. These are three concepts. Kinematics of motion, Newton's laws of motion, inclined plane motion. This is the diagram. 3 points A, B, and C lie on a line of greatest slope of a plane inclined at an angle 30 degree to the horizontal, with AB is equal to 1 meter, BC is equal to 1 meter as shown in the diagram. These are 3 points A, B, C. AB is 1 meter, BC is 1 meter, angle with the horizontal is 30 degree. The mass of the particle is uh, mass of the particle is 0.2 kg. 0.2 kg. The part of a particle of mass 0.2 kg is released from rest at A. This particle is released from rest. Initial speed will be 0 at A and slides down the plane. Its movement will be downward along the plane. The part of the plane from A to B is smooth. This part of the plane AB is smooth. This means that there is no friction. The part of the plane from B to C is rough, with the coefficient of friction is mu between the plane and the particle. This part of the plane BC is rough. This shows that friction will be must be there in part BC of the plane. This is rough. Given that coefficient of friction mu is 1 over 2 under root 3, find the speed of the particle at C. In this part A, we have to find the speed of this particle at point C. So first of all, we will find the speed of this particle after releasing. We will find the speed of this particle A at point B. We have to find the speed of this particle at B. Speed at B at point B, we have this data. Initial speed is 0 because release from rest. Initial speed is 0 and distance is given, that is 1 meter AB distance. And acceleration we have to find. Acceleration will be when we release this particle from rest. Only force that is acting on this particle is the component of the weight which is acting along the plane. So we are resolving the weight first. to show the component due to which it moves along the plane. Weight vertically downward. This is the weight of the particle mg. These are the components. This component is along the perpendicular to the plane, and this component is along the plane. This angle is the same as this angle. This is 30 degree with the horizontal. This is also 30 degree. By using angle properties, this angle is 30 degree. Now these are the components. This is the reaction of the plane on this particle. Reaction will be, this is normal reaction representing by R. Reaction of this plane on this particle, that is R. Normal reaction. So no components are, this component is mg sine 30 along the plane. This component will be mg cos 30. Now this component, this is the force with which this particle moves along the plane. This is the force 0.2 g sine 30 component of weight acting on this particle with which it moves along the plane downward. So from here we can find this is the only force with which the particle comes down along the plane. So using Newton's second law of motion, mg sine theta, mg sine theta is equal to ma. From here m is cancelled out. So acceleration from here is equal to g sine theta. From here a is equal to g is 10 sine theta. Value of sine theta is sine 30 degree, that is 1 over 2. So we get acceleration is 5 meter per second square. This shows that this particle 0.2 kg moves along the plane with from A to B with acceleration 5 meter per second square. We are writing here acceleration is 5 meter per second square. We have to find the final speed at point B. We have to find the speed at B, that is representing by V. So we are using here this equation of motion, V square minus U square is equal to AS. V square we have to find, U square is 0, so V square is equal to 2AS, that is 10. So we get V is equal to plus minus 10 under root. We are taking the positive value of the speed, magnitude of the speed, that is 10 under root meter per second. This is the speed at B. At point B, the speed is under root 10 meter per second. Now, actually, we have to find the speed of this particle at C. Now, we will consider this uh, part of the plane BC. This is a rough surface. BC part of the plane is rough. So, and the coefficient of friction is given, that is 1 over 2 under root 3. So for speed at C, at point C, we have initial speed. Now we are taking this speed we have already found, that is speed of the particle at point B. Now we are taking an initial speed under root 10. Final speed we have to find. Now we will find acceleration and distance we have 1 meter. So for first we will find acceleration. For acceleration, now there are two forces for this part of the plane. There are two forces acting on the particle. One force is the component of the weight. Other force will be force of friction that opposes the motion of the particle, that will act in the opposite direction, that is mu r. F is equal to mu r will act on this mu r force of friction will act on this particle. Then when the particle is at point B, particle is at point B, there are two forces. One force is same, the component of the weight acting along the plane, and the other force is F is equal to mu r frictional force. So at point B, for acceleration, mm, we are using the Newton's second law of motion again. Mg sine 30 degree component of the weight minus mu r force of friction is equal to ma. Now we will put here the value of r. R is the reaction already mentioned in the question. Reaction of this inclined plane on this particle, that is r. R is equal to this mg cos 30 degree component of the weight that is acting perpendicular to the plane. This r is equal to this component of the weight. So mg sin 30 degree minus mu is given in the question 1 over 2 under root 3, 3 under root over 2, and r is mg cos 30 degree is equal to ma. Taking m as a common from both sides, m is common in these two terms, m is common on the right hand side also. There is m, so cancellation of m from both sides. We get g is 10, sin 30 is 1 over 2, so we get 5 minus under root 3 over 2. 10 into sin cos 30 is under root 3 over 2 is equal to a. From here, after simplifying, we get 5 minus 15 over 2 is equal to a. So we get acceleration from here is equal to negative 2.5 meter per second square. Now this is the deceleration of the particle for the motion V to C. We have to find the speed at C. Now we are using uh, this data. Initial speed we have at B. Initial speed is 10 under root. Initial speed is at B under root 10. Already we have found. And final speed we have to find. Distance is 1 meter BC distance, and acceleration is deceleration, that is negative 2.5 meter per second square. Now using this equation, V square minus u square is equal to 2 b square we have to find u square of under root 10 is that is 10 is equal to 2, a is negative 2.5 and s is 1. Now from here v square is equal to v square minus 10 is equal to 2 into minus 2.5 into 1. We get v square minus 10 is equal to minus 5. From here v square is equal to 15. 10 plus 10 minus 5 that is 5. V square is equal to 5 and from here v is equal to square root of 5 that is 2.24 meters per second. This is the speed of this particle. Speed of this particle at c we have found that is uh, 2.24 meters per second. This is the answer. The last part of this question is part B. Given instead that the particle comes to rest at C, find the exact value of mu. In this question, in this part, we have to find the value of mu, but it is given that the speed of this particle at C is 0. Now again we consider the initial speed at B is, we have already found that is mm, under root 10. Speed at B is, we are taking this initial speed, the final speed is 0 because it is given in question, but we need the acceleration. Now we will find the acceleration. First, acceleration again, the two forces are acting on this particle. One force is component of the weight acting along the plane, and the other force that is opposes the motion, that is mu r. So we are finding first the acceleration from and using Newton's second law of motion, mg sine 30 degree minus mu r is equal to ma. Mg sine 30 degree minus mu we have to find, and r is uh, component of the weight acting perpendicular to the plane, normal reaction of the plane on this particle, that is r equal to the component of the weight that is acting uh, perpendicular to the plane, that is 0.2 g cos 30. 0.2 g cos 30 mg cos 30 degree is equal to ma. Again, the m lies in the left hand side. In the both terms of the left hand side, there is m. Taking common from these two terms, m will be cancelled out. So we are cancelling m. From here we get acceleration. G sine 30 mean 5. G is 10. Sine 30 1 over 2. We get 5 minus mu into G cos 30. G is 10. Cos 30 is under root 3 over 2 is equal to A. From here we get A is equal to 5 minus 5 under root 3 mu. This is the acceleration. from B to C in this case, in this part. Now we have to find the value of this mu. Again, we are using this data. Initial speed is under root 10 at point B. Final speed is 0. It is given in the question as BC distance is 1 meter. We are using this equation. V square minus U square is equal to 2 AS. V square is 0. Initial speed is 10 under root. Square is 10 is equal to A is 5 minus, just we have found A 5 minus 5 under root 3 mu into S. S is 1. S is 1 meter. So we get from here minus 10 is equal to 10 minus 10 under root 3 mu. So 10 under root 3 mu is equal to uh, 20. Rearranging from here, mu will be equal to 20 over 10 under root 3. So 22 the 10 to the 20. So we get finally the value of mu, that is 2 under root 2 over under root 3. This is the value of mu. The value of mu for this part, we have found exact value of mu, that is 2 over under root 3. This comes to an end.